Well, hi again, this is Bob, and I'm getting ready to do a redo on Section 5.2. I wish I could explain to you how much problem I've had. Somehow or somewhere, the original recording is floating around in the ether, and the recording program has been very uncooperative, and I've been through about every possible way to get this to work. So hopefully this time we'll have something. So again, this is Section 5-2, Part 2. And fortunately, it's pretty mechanical. We're looking at the variance in standard deviation. And remember that we're still talking about probability distributions, which are the subject of Chapter 5. And we just recently looked at a couple of questions, Example 5.5 and Example 5.6, on how to set up a probability distribution and find the mean. And just as a little reminder, because it's going to come back, you may recall that the mean for a probability distribution is the sum of the x's times the individual probability of each x. So what you may want to do before you start, if necessary, you may want to go back and review Example 5.5 and 5.6. And we know that the root of the variance gives a standard deviation, so we'll just concentrate on the first formula that they give us. And this may look familiar from back in Chapter 3. There's only one problem with this, though. And I could take the root of that for variance, by the way. But the problem is that remember, when we're talking about probability distributions, we know that n is infinite. Okay, so this formula will not work, where it worked nicely earlier when we were finding variance and standard deviation in Chapter 3. Well, this is the formula. And we're not going to go through the derivation, but it's interesting in its own right. This formula that I'm writing now, which is about 2/3 of the way down on page 267, which says the sum of the x's minus the population mean squared times the probability of x. This is how we would find our variance. And again, recall that the square root of variance gives a standard deviation. Well, what the book does, and they don't give us each step, it takes a little advanced algebra, but what they do is, this is a binomial here, and they square that binomial and do some rearranging, and we finally get down to the formula in the highlighted box at the bottom of page 267, and this is the one that we're going to use each time to find the variance. And then, of course, once we found the variance, we take its root and get the standard deviation. Now, again, this formula that I just wrote is a derivation from the formula above it. Okay, and then if you notice on the very next step, if you want the variance, you simply root both. If you want the standard deviation, you simply root both sides, and that is what's shown on the at the right in the box there, the highlighted box. And then they give us a reminder that standard deviation or variance cannot be negative. Okay, so anyway, I wanted to start off, and I will go back and review a little bit on 5.5, but you may remember from Example 5.5 that our mean was 3.5. And what 5.5 asked us was to find the mean and variance well, actually, it just asks us to find the standard deviation. I'm sorry, I'm looking at 5.9, which we're going to do in a second. 5.5 just asks us to find the mean for the roll of the die. And remember that our formula was we had an outcome and the probability of the outcome. And of course, the probability of getting each of these numbers was 1/6. Okay, so again, I'm going back to 5.5 to try to remind us what we did, and then we had the mean equals the sum of the x's times p, the probability of each one. And if you flip back to 266, you can quickly follow their example, and that's how they came up with a mean number for a roll of the die of 3.5. And of course they explained that 3.5 is not a number that comes up on the die, but it represents the mean value for each roll. Okay, well now what we're going to do is we're back over on page 268 again, and we want to compute the variance in standard deviation using our new formula. Okay, so again, I'll write our formula for the variance, which is on the bottom. We just derived this toward the bottom of page 267. And recall that it's the sum of each of the random variables squared times its probability, and then we subtract the mean squared. Okay, so this is a formula that is derived from the one above it, and what we're going to do first is we're going to recall that the mean, since we already did this from example 5.5, and that the mean was equal to 3.5. So we can concentrate on our calculations here. And again, remember that a die can come up 1, 2, 3, 4, 5, 6, and recall also that the probability hasn't changed. It will be 1/6 for each of those. So here's what we do. We go 1 squared times 1/6, then we go 2 squared times 1/6. It's pretty mechanical, as I mentioned. Then 3 squared times 1/6, then 4 squared times 1/6, and then unfortunately I may run out of room here, 5 squared times 1/6, and then 6 squared times 1/6. And then from that, I like to use parentheses, we subtract out the mean squared. So this is all meant to be written out in one line, as they did on example 5.9 on the top of page 268. And you can see that they got 2.917 as the variance. Okay, then we know to find the standard deviation that we would root both sides, and it gives us a standard deviation of about 1.708. You know, that is what that's what we're doing on these. Okay, and that is a really good example of applying the variance and standard deviation of the roll of the die. Okay, and again, we're talking about n being infinite here. Okay, so let's take a look at the next one here. It's example 5.10. And 5.10, it says we've got a box with 5 balls in it, and there are 2 balls that are numbered 3, and there's 1 ball that has a number 4 on it. We'll do everything on this one. And there's 2 balls that have are numbered 5. So we could set up a little probability distribution where we have the number on the ball, and then we have the probability of each one. This is exactly what they did. We had a 3 and a 4 and a 5. And remember that 2 balls were numbered 3. So that probability would be 2 out of 5. 2 balls out of 5 had the number 3. 1 ball out of 5 had a number 4. And 2 balls out of 5 had a number 5. So the first thing, we're going to do everything on this one. The first thing we would want to do is find the mean. And I don't know where that came from. But the mean would be equal to the sum of the x's times px, as you can see. So we would have 3 times 2/5 plus 4 times 1/5 plus 5 times 2/5. And that turns out to give us a mean of 4. Okay, well, we're going to use that in the next calculation here. Okay, and this time we're going to find the variance. And remember that I'll just quickly put the chart back up again here. So we know what we're referring to. 3, 4, 5, 2/5, 1/5, 2/5. And so to find our variance, we square each one of the random variables and it's the sum of the random variables squared times the individual probabilities. And you can follow along with your calculation. So it would be 3 squared times 2/5 plus 4 squared times 1/5. Of course, don't forget we have to subtract the mean squared. Plus 5 squared times 2/5. And from that, according to our formula, we're going to have to subtract out 4 squared. Okay, and that's the step that you see for the variance directly below. And according to the book, that turns out to be 16.45. And I strongly recommend that you verify that. 16 4/5, excuse me. And from that, we're going to subtract 16, and we end up with 4/5, or if you like, 0.8. So let's say that our variance is 0.8. We have to root both sides to find the standard deviation, which they do, and they give it to approximately 0.894. Okay, well, I'm not trying to say that this is that easy of a skill or that difficult of a skill, but in terms of some of the other things we've done which involve a lot of thinking and setup, like some of the probability problems, this one is indeed mechanical if you have the random variables and you have their probabilities. So there'll be a few questions on this in the homework, and there'll be a question or two when we get around to test 2. I could go on with the expectation here, which is the last topic in chapter section 5.2, but I think I'll break that down into a separate section, and I'm just crossing my fingers that it indeed will work. So I'll be back shortly with a redo for expectation at the bottom of page 269. Thank you.